Today we're going to go over lesson 6.4 and 6.5 over a rhombus, rectangle, and squares. So let's first define each of the three words. The first word is a rhombus. This is a four-sided shape that is a parallelogram. So that means opposite sides are parallel in that all the sides are congruent. Next is a rectangle. Again, it is a parallelogram, so opposite sides are parallel, and it has four congruent angles. When you put the two previous shapes together, it forms a square, which is a parallelogram, and it has four congruent sides and four congruent angles. So before we move on, let's go through and list the properties of all parallelograms. Now, first of all, we know opposite sides are parallel. That's by the definition of a parallelogram. Now, there are 5 more rules. We talked about them in the previous lesson. So really, there are 6 things you need to know about parallelograms, but the first one is opposite sides are parallel by the definition. So there are always 2 things about the sides. We already discussed the one thing is the opposite sides are parallel. Next is opposite sides are congruent. Now, there's always 2 things about angles. We know that the opposite angles are congruent, and we also know that adjacent angles are supplementary. So angles that are right next to each other add up to 180. Now, so we have 2 about sides, 2 about angles. We have 1 about what happens when the lines in the middle cross. Those are called diagonals. So the diagonals bisect, and we have the buddy system. So this is one set of sides that's parallel and congruent. Okay, so let's go through and talk about some properties that each shape has in addition to the above properties. Now, the diagonals of this next figure would look like something like this. Now, when you look at those, hopefully you can tell those are not the same length. So if I were to label these A, B, C, D, A to C is not the same length as B to D, but some things do happen. So the diagonals, they are perpendicular. So whenever you do a problem about this, you need to realize there is a little right angle here, so lots of right triangles are formed. So since you have one right angle, technically all of these are 90. So the diagonals are also perpendicular. No, let's see. These are angle bisectors. So what that means is that these angles are cut in half. These angles are cut in half. Now, you might ask why. Now, I can erase this. If I were to scratch out this bottom and just look at the top, do you guys see a triangle? Now, this triangle has 2 equal sides. What kind of triangle has 2 equal sides? You're right, isosceles. So if you have 2 equal sides, that means you have 2 equal angles. Now, we have a picture here. If I go back to the original picture, we have 4 equal sides. So that means when we do this, opposites are going to end up being congruent. So those are angle bisectors. Now, when you have a rectangle, let's draw in these diagonals. Now, do they look the same length now? And hopefully you're saying yes. AC is the same length. It is congruent to BD. So the diagonals are congruent. They are not perpendicular, though, here in the middle. So the only thing you need to remember are that they are the same length. So a little hint. This is the way I always remember it. When there's right angles here, that means these diagonals have to be the same length. So on the previous, you didn't have the right angles at the vertex. So you know that the diagonals are not the same length. Now, on the next shape, you do have the right angles. So what does that mean? That means these diagonals, if I could draw them in properly, would be the same length. A square is both a rhombus and a rectangle put together. Okay, so lots of things happen. So a right angle is formed there in the middle, and it is also congruent here. I got to put the right amount of little marks. So there's a lot happening with the square. Now we're going to decide if the parallelogram is a rhombus, rectangle, or square, just looking at the information provided. So on part A, we know opposite sides are equal, but they're not all equal with each other. So this would have to be a rectangle. So for part B, you have all equal sides and all equal angles. So this is a square. On part C, we have all equal sides. So this is a rhombus. Now D is a very tricky one. Now we know that these sides are parallel, and that has to be a hint for something. So if this is my transversal, which I can do since I know I have the two parallel lines, if this one's 90, I know these two angles would have to add up to 180. So if the first one is 90, that means the second one also has to be 90 because 90 plus 90 is 100 or 180. Now we can also figure out that over here opposite angles are equal and that those are all right angles. Now, is this a rectangle or is this a rhombus or a square? Now, do we know anything about these sides on the left and right? No, we really don't. We don't know that it's the same measure as the top and bottom. So I'm going to say this is a rectangle. Okay, so for the next part, you will need a calculator. Now we need to also know that triangles all add up to 180 degrees. Now when I first look at this, I'm going to see that, for instance, that's a triangle. And I can figure out some of these angles quickly. If I have two equal sides, that means I have two equal angles. So angle 3 is also 54 degrees. Now, since angle 3 is 54, I know angle 2 is also 54 because it was an angle bisector. So how do I find angle 4 and angle 1? Well, I know opposite angles are equal, so they're going to be the same thing. So what I'm going to do is I'm going to take 180 and subtract 54 and subtract 54. So 180 minus, that's 108, is 72. So that means both angles are 72 degrees. Okay, let's try the next one. What shape is this? This is a rhombus. Now, just looking at this quickly, I know that 2 and 3 are going to be the same once I figure out the number. And this is a big triangle with two equal sides. So again, we can figure out that 1 and 4 are the same measure. Okay, so let's come up with a plan here. Now we know this is an angle bisector, so this angle up here is really 52 degrees. So on this big triangle again, this top angle is 104 now. We can figure out angle 1 and 4 from that by taking 180, subtracting 104, which is 76, and then dividing 76 by 2, since angle 1 and angle 4 are both equal in measure. So 76 divided by 2 is 38. All right, angle 1 equals angle 4, which is 38 degrees. Okay, so let's find angle 2 and angle 3 next. We know they're both going to be the same. So let's just zero in on this yellow triangle. So in a triangle, I know I have 180 degrees. Let's subtract the two angles that I already know, the 52 and the 38. So if you like, you could add the 52 and the 38 to get 90 and then subtract it from 180, or just take 180 and subtract the two angles. Either way, you get 90. Now, could we have figured out the 90 from the beginning? You probably could have, because if you look back up here at a rhombus, what happens always? They're always perpendicular. So that one we could have found much easier, but we found it regardless. So angle 2 is going to be 90, and since they're vertical, they're both 90. For example 3, we have a rectangle. So I like to see this picture, so I'm just going to draw just any old rectangle. It could be a sketch, it doesn't have to be pretty. When you label the sides, they need to go in consecutive order. So start with the side and just go around like a clock. You're not allowed to skip around. So H to J, so that actually is a diagonal, is 4x, and I to K, that's another diagonal, is 7x minus 12. So now that you see the picture, what do you know about these diagonals? Hopefully you know that diagonals, when you have the right angles, are equal. So to solve this, we're just going to set them equal to each other. Now normally I would take the 4x over to the right, but since the 4x is over here by itself, I'm going to actually go against what I normally do and subtract the 7x and get a negative 3x equals a negative 12. And then divide by negative 3, and a negative over a negative is a positive. Okay, so let's read the directions to make sure we're finished. It says find the value of x and the length of each diagonal. Okay, so we found x. Let's plug it back in. So 4 times 4 is 16. So HJ is 16. Now, when I plug it into the other one, if I don't get 16, then something is wrong. So let's try it. IK, 7 times 4 minus 12. So 7 times 4 is 28, minus 12 is 16. Okay, that's good. They're the same, and they should be, because diagonals of a rectangle are equal. Okay, for the next one, it looks like we have the same diagonals, but they provided us with new side lengths. So to solve this, again, we're just going to set them equal. And then let's do some algebra. Take the x over, divide by 4. So x is 10. So when I plug this back in, again, our diagonals should be equal. So 10 plus 40 is 50, and this was HJ. When I do IK, 5 times 10 is 50, and they are the same. Okay, determine whether this statement is true or false. If false, rewrite this sentence to make it true. If it's true, list any other quadrilaterals for which the statement is true. Okay, there's lots to do here. Rectangles have 4 congruent angles. So let's go back and look. Do rectangles have 4 congruent angles? Of course they do, right here in the middle. So what other shape has 4 congruent angles? And there's only 2 other choices. We know it's not a rhombus, so it has to be a square. The diagonals of a rhombus are always congruent. So let's go back and look. The diagonals of a rhombus are always congruent. So we're looking here. Remember, A to C and B to D are not the same length. So the diagonals of we could say square, are always congruent. So the first one was true. The second one is false. And I rewrote it, and I'm also going to include that a rectangle would also work. For example 5, find the values of the variables, then find each side length. Okay, so if this is a square, even though it really doesn't look like a square, we know all of the sides are equal. So to solve, we're just going to set them equal to each other. So to solve this, I'm going to subtract x, and you can use the calculator. 3/5 x minus 1x is a negative 2/5 x. Okay, so to solve this, I am going to multiply by the reciprocal. So that means I'm going to flip the 2/5 and make it 5/2. Now it is negative. So a negative times a negative is a positive. The 5s will cancel out. The 2s will cancel out. So I'm left with x, which is good. Now on the right side, a negative and a negative turn into a positive. 2 goes into 8 4 times. So 4 times 5 is 20. And it says find the length of each side. So now we need to take the 20 and plug it back in. So 20 minus 8 is 12. So 3/5 times 20. Okay, so what we need to do is say 5 goes into 5 once, and 5 goes into 20 4 times. So 3 times 4 is 12. And notice they are the same. A rhombus, all the sides are equal, so we're going to set them equal to each other. And then we're going to use algebra to solve. So 2m equals 12. Divide by 2, and m is 6. Okay, let's plug it back in. So 3 times 6 is 18. And then 6 plus 12 is 18. Can you conclude that the parallelogram is a rhombus, rectangle, or square? Now, on this problem, I know opposite sides are parallel, which just means it is a parallelogram, which they provide that information in the beginning. Now, I also know that these angles are all equal. I kind of like putting the little slash in it. Now, I can use the third angle theorem that says if two angles are the same as two angles in another triangle, then the third angles have to be congruent. Okay, so I know opposite angles are congruent. So let's go back and look. Can we conclude from this that it is a rhombus, rectangle, or square? Now, I think that rectangle is definitely out, because if you look here, we don't know that these are the same measurement. The only thing it possibly could be is a rhombus. So if you have these angles that are the same, the diagonals are angle bisectors, that's going to be true every time. But here's the issue. Do we know anything about this diagonal, F to D? And we don't know anything about it. So we conclude it's parallelogram from this information because opposite sides are congruent, or opposite angles are congruent. But I'm going to say we cannot conclude that it is any of these, because we do not know anything about this diagonal. So this one is none. We don't know anything about FD. Okay, on the next one, we know that N to P and O to Q are congruent. Okay, so that's promising. They're the same measurement. Let's go back and look. When you have a rectangle, it says the diagonals are congruent. Now, do we know about both of them? We do. We have both diagonals. They're both congruent. So this is definitely a rectangle. So when you have a rhombus, what do you know about the angles? And again, we can always keep looking back at these. So when you have a rhombus, we know that you have angle bisectors. So all these little angles that are right next to each other are all congruent. So when you look at this problem, it's pretty easy to solve because you know that these two angles are really just congruent. So to solve, we're just going to write a little algebra equation and solve it. So let's set them equal and then subtract 6x and then add 1. So 33 equals 11x, and when I divide by 11, I get x is 3. So let's read the directions and see if we need to plug it back in. This is for what value of x is the figure for what value of x is the figure the given special parallelogram. Okay, so you don't have to plug it back in. For part B, it's a rectangle. For a rectangle, all of these little pieces inside are equal. And they even tell you that they're equal down here. So what we could do is we, again, could just set up a little equation and solve. Now, again, I normally would take the 5x over and subtract it. But if I do that, here, don't do this, but I'm going to do it. If I do that, do you guys notice there's nothing left on the right and everything's on the left, which that usually causes lots of confusion. So I'm not going to do it. I'm going to subtract the 6x from the left over to the right. So I'm left with negative 3 equals negative 1x, and then divide by negative 1, or you can times by negative 1, and my answer is positive 3. Okay, when you have a square, remember these are all right angles, but it also has the qualities of a rhombus, so that means these angles are actually being cut in half. So what's half of 90? Half of 90 is 45. So this angle, 7x plus 3, is really equal to 45. And we can solve it from there and be finished. All right, so grab your calculator if you need to, and let's solve it. All right, 7x equals 42, and divide by 7, and x is 6. Example 7, determine whether the parallelogram is a rectangle, rhombus, or square. Give the most precise description in each case. The parallelogram has perpendicular and congruent diagonals. Okay, so let's go back and look. Perpendicular, so if they have perpendicular diagonals, it would have to be a rhombus or a square. But a big hint is that they are congruent. So the diagonals are congruent on a square. So this answer has to be square. A parallelogram that has perpendicular diagonals and the angle measures, they're all 90. So if they're 90, that means it has to be a rectangle or square. If it has perpendicular diagonals, we know it's not a rectangle. So my answer again has to be square. All right, guys, I believe that's it. If you have any questions, please let me know.